In this lesson, we will use the Tcpdump utility to assess organizational security. We are in the Tcpdump portion of the video series. This lesson is part of a video series that prepares you for the hands-on portion of the CompTIA Security Plus exam and is designed to give you hands-on experience with the exam. So what is Tcpdump? Tcpdump is a powerful command line tool for capturing and analyzing network traffic. Network administrators, security professionals, and developers rely on Tcpdump to monitor and troubleshoot network communications. It is typically used when you need to diagnose issues, analyze traffic, and ensure everything is running smoothly on your network. You can run Tcpdump on Linux or Unix systems, capturing packets directly from a specified network interface. The tool is essential for detecting issues, monitoring network performance, and identifying potential security threats. To use it, simply execute the command with various options, such as specifying network interfaces or applying filters to capture relevant data. The rest of this how is what this video is all about, so let's get into it. To get started, grab the companion guide from the link in the show notes below. Also, if you like this content, please make sure to subscribe to the channel so you won't miss any new videos. So we're all set. We have our companion guide on the left, we have Ubuntu Linux on the right. So let's go ahead with the first step where it says launch a terminal on our Ubuntu machine. So I'm going to use the Control-Alt-T method. That's going to launch a terminal. I'm going to double click on the menu bar to make it full screen. I'm also going to increase by going into view and making this, I'm using the shortcut Control++ on my keyboard to make this a little bit bigger. Okay, so we're all set up here. The first thing we want to do is make sure we have Tcpdump installed. Now I'm going to do the sudo apt update just to make sure, see what available updates are there. It's going to ask me for my sudo password, so I go ahead and do that and wait a minute. That took about 15 seconds and it sees it has a couple of 8 packages can be upgraded. At this point here, I'm going to clear the screen. Obviously spell that properly. We're going to do sudo apt install and I want to install Tcpdump. Now we can bring in the Kali Linux environment, yes, for sure, which has all of these pre-installed, but the idea is to do this so that way if you don't have this on your own version of Ubuntu, you know how to install it. Okay, so we see that it's already installed. I was all set. So I'm going to clear the screen here one more time so we can see the sudo Tcpdump version. So I'm going to do sudo Tcpdump tac version and see what are we working with here. And we see we have Tcpdump version 4.93. That means we're all set. So we can go ahead and do our housekeeping on this side and go into our setup. So the first thing we want to do is make sure that our Ubuntu and Kali Linux hosts are on the same subnet. So it means that we have to go back and take a look at our network setup here. And let's just take a look at what we have. We have our Ubuntu machine. Let's see what IP address we have. There's a couple of ways we can do that. One is IP adder. So I'm just going to do IP adder and I see I have the 172.16.1.102 assigned here. That's fine. We have a local loopback. It's sitting on this Ethernet interface here. Okay, great. That's one thing we can do. I can also do hostname. So if I want to take a look at the IP address, I can do hostname minus uppercase I. It gives me this IP address. Great. I also have a Linux Ubuntu tucked behind here. So this is this box here. Behind the terminal here, I have an a Linux machine. So I'm going to right click, open a terminal here. And I'm going to do the same thing, Control++ to get that terminal session up and running. And let's take a look at that IP address, hostname minus I, and I have the 172.16.1.103. Yes, indeed, these two are on the same subnet. So you can see that here with the hostname 172.16.1.102. And I just want to see if we have ping capabilities between these two. So this is going to be real easy. I'm going to ping 172.16. Well, it's good to have the numlock on. So if you run into any of those issues, sometimes you have to have the numlock on your machine. I'm going to make it 102. And yes, I can now ping from the Kali Linux host to the Ubuntu host. So this looks fine here, okay? It says it's unreachable, and let's see what this issue, let's go ahead and do some live troubleshooting. I'm going to Control C
after
to
quick
stop. Troubleshooting, we see that the issue is that we have the wrong IP address, right? So I have to make sure it's 102. So let's do this correctly. We're going to ping 172.16.1.02, and we should have healthy returns. ICMP, Internet Control Message Protocol, we're getting some healthy ping replies, so that means we can ping from Kali through the switch to the Ubuntu box. Let's see if the reverse is true. Let's go here. We're going to clear the screen. I can host name so you can see that. I'm going to ping the 172.16.1.103. Let's see what happens here. And yes, I can ping. So we make sure we have connectivity here. So this is fine. So I'm going to Control C to stop that ping. And I also want to see if I can ping through the switch and all the way through the other side of the pfSense router. The pfSense router is this device here. We have it all set up. It's tucked into our network. There are video links in the description on how to set up this lab environment. So I'm going to clear the screen to bring this back on top. And in this case here, I'm going to ping Quad 1 Cloudflare. And I see that I do have successful traffic that is going from the Ubuntu machine through the switch out to the pfSense router to the wide area network all the way out to Cloudflare and coming back. So this looks good. Let's see if we can do the same thing on the Kali Linux side. I'm going to clear the screen and I'm going to have a continuous ping going on the ping side. I'm going to ping the same thing. This time let's go to Google's DNS. And we are successful. So we have the Ubuntu machine pinging to Cloudflare. I have the Kali Linux machine pinging through the switch, through pfSense, and going to Google's DNS. That's fine. So for the purpose of the lab, I'm going to keep this Kali box continuously pinging over to Google's DNS so we can run some TCP dumps and get some packet captures. I'm going to stop the one here on the Ubuntu, clear the screen to get it back on top, and go to our companion guide. And let's see if we did everything that we were supposed to do. First and foremost, we're going to ensure that both the Ubuntu and Kali Linux are on the same subnet. We checked that. That's great. We made sure that they can ping each other and the outside world. And we have a continuous ping going on the Ubuntu, on the Kali Linux, pinging the Google DNS. Okay, great. So the first thing we want to do is take a look at the interfaces. What are we going to listen to with Tcpdump? So we know we have an Ethernet interface on this one, so let's go ahead and run the command. So it's sudo tcpdump -d to see the interfaces, and I see we have a number of interfaces. We have a loopback, we have an Ethernet interface, it's up and running. We have a couple of other interfaces here. I can back this up by doing an ifconfig to see the interfaces, and I see this is the interface that I want to monitor. And I also have a loopback. So this interface here, the 176.16.102, or more specifically, this interface here, this network interface here is the one that I want to act as my listening or packet capture. Okay, so this is good. It may be on other devices, you may see a slightly different look, and maybe it's worth it to go take a peek at that on the Ethernet side of Kali Linux. So I'm going to keep that continuous ping going. I'm going to do a new tab, make this a little bit bigger, and run the same command that we ran on the Ubuntu side on the Kali Linux side, sudo and tcpdump. So let's just do the sudo tcpdump -d. Of course, we have to put in the Kali, and you see I have a slightly different looking named Ethernet port here. It's up and running also. So I'm just going to do an ifconfig, and we see we have ETH0, Ethernet 01, Ethernet card 01. This is a more of an older standard. This is what Kali Linux is using. On the Ubuntu side, we're using ENPOS as our Ethernet card, and that's what we'll listen to. Okay, so let's go ahead and clear. I'm going to run the first command that we have here, listening on that interface. So we're going to do sudo tcpdump -i to select which interface we want to listen to, and it's going to be the NP0 Sierra 3. I go in and I see those ping traffics that are going back and forth. So this is listening on this whole network, and I can hear the Kali Linux box, the 103. Let's go back to our map. I'm here listening to traffic on this whole domain. There's only one host here, So this is all the noise that's being made, or the only traffic that's being made on this interface. So we'll go back, and I see this is a continuous ping on the Kali side, so I can see the ICMP echo request, ICMP echo replies. Let's Control C to close this and add another flag to this here so we can actually see the IP addresses. So we're going to throw the -n, do not resolve hostname, no hostname resolution. So we're going to do -n, and this time we only want to see the IP addresses. So this is Google's DNS going 8.8.8, doing an echo reply to 172.16.1.103, the Kali box. This is the Kali box pinging, making an echo request to the Google DNS 8.8.8, and so on and so forth. In other words, we're looking at this traffic here, 8.8 coming in through the router, the switch going to Kali, and we're listening through the broadcast domain sitting on the Ubuntu box. Once again, the Kali Linux on this side here has continuous ping going to Google's DNS, and we can hear that traffic and capture that traffic on the Ubuntu side. Realistically, that's all there is to it, but we're going to do some more work on this here and look at different ways we can capture the traffic. So I Control C anytime I want to stop the capture. So here's the capture happening now in real time. If I want to stop it, I do Control C and I stop that capture. So let's do some of our housekeeping and let's limit the number of packets. Maybe we just want to, let's say, only capture 10 packets, let's say. So in this case here, I'm going to do sudo TCP, and we're going to limit the count. So I'm still calling out the interface, and in this case here, if you see the command, it's -C and the count. I only want 10 packets, and I still want to do the name resolution here, or actually without name, -n is without name resolution. So I'm going to do this, and you're going to see only 10, right? A little noisy or not as clear. So if I bring it on top and do the -n for no hostname resolution, looks a little bit cleaner, and we're only going to capture 10 packets so we can see that traffic a little cleaner. The Kali Linux sitting on 1.103, pinging 8.8.8. We see the request. 8.8.8 pings back 172.16.103. It gives the reply, so on and so forth, until we have 10 packets captured. So this is how we can limit the number of captures or packets. Okay. Now, let's go by protocol. So if you notice, it was happening almost instantaneously. I can take this command here. I'm going to clear the screen on this side here and replicate the command on the side, on the Ubuntu side. So essentially, I just want the interface, so we don't want to do the name resolution. I'm going to back out the count, and I just want to see and capture TCP traffic. And as you can see, there's no TCP traffic happening here because the only thing that we have are 2 hosts on this network, and the one host, the Kali Linux, is only generating ICMP traffic. So I'm not expecting to see anything here because I'm filtering by protocol, TCP type. However, let's Control C to stop. Now let's look at ICMP traffic, Internet Control Message Protocol. If I want to look at ICMP, I could start seeing ICMP traffic again without touching the Kali box. So I see the full return trip. Pinging in, pinging out, the reply going in. Echo request, echo reply, echo request, echo reply. Okay, great. So I'm going to Control C again, clear that. Let's listen to some UDP traffic. And I have, well, you got to spell it right, UDP traffic. And now I'm listening for UDP traffic. And let's generate some UDP traffic on the Kali side. So first and foremost, let's go to our TCP UDP ports. And I'm going to release the IP address using the release command. And I know that we're using DHCP. So we have DHCP assigned IP addresses. We have a DHCP server that's on UDP. So the server is on port 67. The client is UDP on port 68. We have DHCP service enabled on this router, which is also doling out the IP addresses here. So let's go ahead and actually see this in real time. So we have the capture. I'm going to slide this over so you can see this in real time. I have Kali Linux now on the side. I'm going to let this ping run. It's okay. I'm going to come back to the desktop here, And we're going to do a couple of things so we can see this a little bit easier. So first and foremost, I'm going to grab the IP address so you can see that. I'm also going to do IP adder so you can see that it has an IP address. And now I'm going to release it. So I do sudo dhclient -r, and we just released this IP address back into the DHCP pool, and we can see that traffic. We see that traffic coming into the pfSense router, and it is releasing that IP address. Okay, great. Now we're going to do the same thing. Again, this is UDP traffic that we're looking at here. If I want to, I can Control C if this gets a little bit noisy in terms of host name, and we can still put in the -n for no host name resolution. So all we see are the IP addresses. So this can be a little bit clearer. So we have the UDP. Now we're going to ask for this IP address, but before, let's see if we still have one, which I don't expect to have one. So I'm going to come back on the Kali side. Host name is empty. IP adder shows that I have no IP assigned here. Good. I'm going to clear the screen to get it back on top so we can see this a little bit easier. Once again, I have no host name, no IP assigned to this DHCP, to this interface. I'm going to call the DHCP command again, sudo client, and now I'm going to just call it out, which is go out to the DHCP server and say, let me get a fresh IP address. And now we can see that boot P or that DORA request, the discover, the offer, the request, and the acknowledgement. So we have a new client here. We saw that traffic. This is the pfSense router giving a new IP address to the Kali Linux. This is all on UDP. We see the port 68 for the client. So we're good here. We see port 67 on the router. Let's see if we have new IP addresses here. IP adder. I have now a new IP address. It's different than what we started with. That's fine. And we also can go ahead and look at the host name, and we see now we have an IP address. But the thing that I wanted to show is with Tcpdump, we can actually filter by protocol. So we can see TCP traffic if we wanted to. We can see hosts. We can see TCP if we wanted to, or ICMP. We can filter by protocol is the point of that side. So I'm going to bring this back to uncover Kali Linux because it still has that continuous ping. And while I'm at it, let me just take a peek and see if that's true. Yeah, the continuous ping is still happening, so we can continue to monitor traffic in this environment. So let's go ahead and do our housekeeping. And I'm going to Control C to stop that traffic on the Tcpdump. I'm going to clear. And now, let's say we had a multiple host on a network and we just wanted to follow traffic on a single host. Now keep in mind, this is a very simple network with only 2 hosts. Tcpdump running here and only one other endpoint generating traffic. So that's the only thing I'm going to hear. If we were, let's say, working for a hospital or a corporation and this was a subnet that had 100 hosts, we would see a lot more traffic. So we're going to come back here, and this time I'm going to call out the specific host. Now keep in mind your IP address will probably be different because we had to change, and I have a different IP address now. And let's break this command down a little bit so we can get a better understanding of it. So we need to super user do because we're running Tcpdump. We're calling out the interface, which is this Ethernet interface that we identified with the -d or ifconfig. And now we want to listen to a specific host. We want to not resolve the host name. In other words, we don't want host name resolution. We want the IP address, and we only want to capture 8 packets. Let's see what happens. Okay, so we captured only 8 packets, and we see specifically this traffic here. We have isolated that host. We see specifically 172.16.1.104, which is the Kali Linux's new IP address to the DHCP, and we see those. Now, let's say we only wanted to see the source IP. In other words, where is it coming from? Only inbound traffic. So I'm going to bring the command back up here, and rather than host, I'm going to do source. And in source, you see the echo request. So we're seeing the source IP making an outbound request. Let me clarify that. Making an outbound request. So the 176.16.1.104 is making an echo request reply. So we're seeing source IP traffic. In other words, traffic that is coming out of this Kali Linux box. Keep in mind the IP address changed because we released it into the pool and we got a new one when we asked for a DHCP DH client. So we're seeing the source, only source traffic. Notice it's only requests. And this here, we get the full round trip, request and reply. Let's do this another way. Let's look at destination, inbound. So we only want to see inbound traffic. So I'm going to bring this up. And at this point, I should only see replies. So I'm going to do DST and only traffic that is destined for 104. And I see 8.8, everything is reversed. 8.8, only traffic that's coming, it's only the replies and only 8 packets. So the other way to say this here is that we can filter by host to see traffic going in and out. We can filter by host and only source IP to see traffic that is going out of that interface. In other words, generating traffic. And then we can filter traffic to an inbound, which is the destination. And we just saw that here. We can also look at a TCP traffic, and let's go ahead and see that on a, let's see, Tcpdump. Let's go look at it from a port perspective. So I'm going to clear, and we're going to run this whole command. Let's just build it out. And I'm going to do sudo tcpdump -i en, that's the interface that we're listening to, and port 80. And we only want to hear port 80 traffic. Okay? So on this point here, I'm going to just bring in the Kali box, let this continuous ping happen, and I'm going to just curl the router. I'm going to clear, and we know pfSense is sitting on the gateway. I know that for a couple of reasons. We have a map, but if I want to, I can do an nmap. I can also do an ifconfig, and I know that we can get out of this interface a variety of ways, which is the 176.1. But to make this real easy, I'm going to just curl. We saw that on our previous one of the lessons, and we're just going to curl the router, and we see that we were able to pull the index.html. It has port 80 running on it, and we're able to pull that traffic that's only destined for port 80. So in addition to following the entire subnet, a host, inbound and outbound traffic on the host, different types of protocols, we can also do by port number if we wanted to also. And that's what we wanted to demonstrate here. So I'm going back to the continuous ping. I'm going to Control-C to get out of this. I'm going to clear the screen and then bring the Ubuntu box back onto this side here. As you can see, this is a very, very powerful tool in terms of network traffic analysis. So now this is all in real time. We would lose everything unless we were to save this into a PCAP file. So let's go ahead. I'm going to take this command. I'm going to copy it into clipboard, bring it over into the Ubuntu side, and it's sudo tcpdump, call the interface, and we're going to write to a file called capture.pcap. So now what's happening is everything that we saw before on the screen is now being written to a file, so that way we can analyze this at a later point. So you have a PCAP file as part of the PCAP library where you can use other utilities to actually read it. So it's happening nice. We're capturing a few packets. I'm going to use Control-C to stop that. It says 48 packets received by filter. I think we should have enough. Let's do an ls to see if we have the capture file. And we do have a capture file. I'm going to try and read it. I know it's not readable. I just want to give you an example here. I'm going to cat the file, and you see that it's not readable. So we need to run this particular command. We need tcpdump to read the file. So we're going to do tcpdump -r to read this capture file. And now we have this capture file that we can read, and it's going to give us the traditional information we saw beforehand, which was DNS or ICMP traffic going to and fro the 172.16.1.104 to Google's DNS. If I didn't want this resolution, I would have thrown in the -n and said, instead of the name resolution, give me the IP address. And that's why we were using the N flag. One more thing that we're going to do, and it's going to tease the next class, is the PCAP file. This is all command line utility. I can actually use a graphical utility called Wireshark, and we're going to use Wireshark to open this capture.pcap file, because Wireshark reads PCAP files and also Tcpdump as well. And now this is going to give us a graphical interface, and we can do more things with this capture file. Now this is more of what we were looking before, but now we can actually start looking at this packet from the OSI layer. Watch it come up the frame, come to the data link layer, it comes to layer 3, which is IP, and then we come to layer 4, which is the Internet Control Message Protocol. If it was TCP traffic, we would see it all here. So we have a whole video teed up on this to discuss Wireshark, and this tees it up nicely. The point of this lesson was to introduce Tcpdump as a protocol analyzer or a network traffic analyzer. Of course, with all of our tools, I'm going to close this, make sure it closes out with the Control-C. We can always get help with the Tcpdump, which is Tcpdump tac help. So 2 dashes will give you the help command. And of course, if you want a little bit more, you can do map Tcpdump man for the manual, and it'll give you a more robust manual and more details about how to use the utility. So once again, this is it at a high level. The idea is to introduce these tools to you so you can put it into your toolbox. As we continue our journey into cybersecurity, we will put all of these tools together in a series of videos that says, well, putting it all together. But for now, I hope you enjoyed the quick intro into Tcpdump. I'm looking forward to seeing you at the Wireshark lesson. See you soon.